Hey everybody, and welcome to another finite math lecture. Today we're going to be doing examples of this type. Determine, using Venn diagrams, whether the following sets are equal. A union B intersect C, and A union B intersect A union C. You might remember in an earlier lecture that actually we should know that this is true. It turns out that the operation of union distributes over intersection. What that means is that if we have a set in union with an intersection, this set and the union operator will distribute to each of these sets. So we should get A union B intersect A union C. That's what the distributive laws tell us. But we're going to pretend that we don't know this, and we're going to use Venn diagrams to determine whether these two sets are equal. And since I guess we know that they're already equal, we're going to use Venn diagrams to confirm that these two things are equal. So the first thing that we do is we draw our Venn diagram. Oops. And we've got set A, we've got set B, and we've got set C. And everything outside each of these sets is part of the universe. Actually, every element under consideration is part of the universe. We'll call this region 1. What we're doing now is we're labeling the disjoint regions of our universe. If we have 3 sets, these 3 sets can be used to partition the universe into 8 disjoint regions. Going across the top, region 1, 2, 3, and then from left to right going across the middle, we have 4, 5, 6, and let me make sure this really looks like 4. Down here, this is region 7. And everything that is outside of set A, set B, and set C is region 8. Region 8 is the set of all elements that belong either to set A, set B, or set C. Okay. We'll work with this set first. And if you'll excuse me, I think I'm going to rewrite the 2 sets and put them up here just to give me a little bit extra board space. We'll work with this set first and clearly identify all of the disjoint regions in the universe that are contained in this set. And we'll do it piece by piece. We'll work with the ugliest part of this set first, B intersects C. And to get B intersects C, I'm going to write down all of the regions in set B and all of the disjoint regions in set C. Let's see. Everything in B is in this circle, so that's regions 2, 3, 5, and 6. B contains regions 2, 3, 5, and 6. 2, 3, 5, 6. Check. Region C. everything in region C is contained in the C circle. And that means we have regions 4, 5, 6, and 7 in region C. 4, 5, 6, 7. Now we'll get to the ugly part. B intersects C. B intersects C, that's the set that contains all of the elements that are in both set B and set C. Another way of saying this is that B intersects C contains all of the disjoint regions that are contained both in set B and in set C. Now let's see, which disjoint regions are common to both? 2 and 3 are in B, but they're not in C. Region 4 is in C, but it's not in B. Region 5 is in both. And region 6 is in both. Okay. And region 7 is in C, but it's not in B. So it looks like regions 5 and 6 are in B intersects C. Bravo. We got B intersects C. Now let's try to get the whole thing. We want A union B intersects C. And to start things off, I'm just going to write down everything that's in set A. Set A is everything in the A circle. That's region 1, region 2, region 4, region 5. So set A contains region 1, region 2, region 4, and region 5. Now that I've got that, I can do A union B intersects C. A union B intersects C. And what is this? This is the set of all elements that are in A, plus all of the elements that are in B intersects C, plus the elements that are in both. So any region that is in either one of these regions, A or B intersects C, is going to be in A union B intersects C, and vice versa. So let's see what we have. In set A, we have 1, 2, 4, and 5. We also have region 5 and B intersects C, and we have region 6 and B intersects C. So we have defined, in terms of disjoint regions, we have defined A union B intersects C. And A union B intersects C consists of regions 1, 2, 4, 5, and 6. Now, we're going to do the same thing for this set. Okay, we've done A union B intersects C. And I've written the results across the top of the board so that we won't have to trust this to memory. This is what we've established so far. Now, we want to do the same thing for the set A union B. And intersect A union C. And in keeping with tradition, we're going to do the ugly parts first. A union B, that looks pretty ugly. Here's what I'm going to do. Let's write down everything in set A and everything in set B, and then we can compute A union B. So here's set A. Here's set A, and A contains regions 1, 2, 4, and 5. Let's write that down. 1, 2, 4, and 5. Now we're going to do the same thing for region B. Here's region B. B contains regions 2, 3, 5, and 6. So we'll write that down. 2, 3, 5, and 6. Now that we have A and B, we can compute A union B. A union B. And remember what A union B is? It's the set of all elements contained in A plus the set of all elements contained in B plus all the elements that are in both. The elements that are in A, 1, 2 is in both, 3 is in B, 4 is in set A, 5 is in both, and 6 is in B. So A union B contains regions 1, 2, 3, 4, 5, 6. That's the first ugly set that we have to deal with. This is the next ugly set right here. A union C. So I'll write down the regions that are in set A again. 1, 2, 4, and 5. And I'll write down the regions that are in set C. 4, 5, 6, 7. Okay. A union C is the set of all elements that are in A, the set of all elements that are in set C, plus the elements that are in both. Or the regions that are in set A, the regions that are contained in set C, and any that are contained in both. So we have region 1 and region 2 in set A. We have region 4 and region 5 in both. We have region 6 in C and region 7 in C. So A union C is 1, 2, 4, 5, 6, 7. So we've got this ugly set computed. We've got A union B, we've got A union C. Now we just have to do the intersection of the two. So what I'm going to do to make this a little bit easier, I'm going to take A union B and rewrite it down here. That's 1, 2, 3, 4, 5, 6. Okay. 1, 2, 3, 4, 5, and 6. And we're looking for the intersection of A union B and A union C. So this is what we're after. A union B intersect A union C. This is the set of all elements that are in both A union B and A union C. To be in this set, they have to be in both of these sets. So let's see. Regions 1 and 2 are in both of those sets. Region 3 is in A union B, but it's not in A union C. Region 4 is in both, and region 5 and regions, oh wow. Region 4, region 4, region 5, region 5, region 6, region 6. Region 7 is in A union C, but it's not down here in A union B. So the regions that we've circled are in both of these sets. They're in the intersection. So let's write those down. 1, 2, 4, 5, 6. This is A union B intersect A union C. And in just a moment, I will rewrite that up here so that we can compare the results. Okay, let's check our results. A union B intersect C is regions 1, 2, 4, 5, 6. A union B intersect A union C contains regions 1, 2, 4, 5, 6. Exactly the same set of regions. Here's the bottom line. These two sets contain exactly the same regions, so that means that the two sets are equal. Now you might be thinking, oh, for crying out loud, that took more than 15 minutes. Yeah, it did. But we got the exercise right. And we're sure that we got it right. That we took the time to do it right, we got the right answer. And this is how we get a 100 on each of our tests. We get a 100 on our tests 10 points at a time. Every time we get an exercise correct, that's 10 points more that we have in the bank going toward a 100. We're college students now, and it should be our aim. If we're aiming for an A, that's not good enough. We should be aiming for 100. We need to set standards for ourselves, and our standards should be high standards. An A is good. But we should prepare for a test and study for it and do our homework in preparation of the test as if we fully intend to get a 100. There used to be a commercial on TV about 30 years ago. This Chinese guy was selling a course on how to flip houses and so forth. And one of the things that he said was, ancient Chinese proverb, if you aim at nothing, you will certainly hit it. And there's a lot of truth in that. If we aim for a 90, which is an A, we might hit it, but if we miss, we're not going to get above 90. If we aim for a 90 and miss, we may get an 80 or a 70. But if we aim for a 100 and we miss, okay, we get a 93. That's still an A. We need to set standards for ourselves and hold ourselves to these standards. It will make a big difference, not just in this course, but in life in general. When we prepare for a test, we prepare for it as if we intend to get a 100. And if we screw up, okay, big deal. We'll get a 93 instead of 100. We can live with that. So, did it take a while to do this exercise? Yeah. But we did it very methodically, and we did it in such a way that we made sure that we were getting it right. So let's do that. And let's make sure that on this test coming up, we study for it, do our homework for it in such a way as to show that we are preparing to get a 100 on that test.